Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on simple harmonic motion from March 2022, Paper 4, Variant 2. In this question, we will discuss some very important points about simple harmonic motion. And those concepts are very important to understand simple harmonic motion in depth. For this question, it is given to us a small wooden block cuboid of mass small m floats in water as shown in figure 3.1. The top surface of the block is horizontal and has area A. The density of the water is rho. For part A, we need to state the names of the two forces acting on the block when it is stationary. When the block is stationary, so simply we can understand block is in equilibrium. So simply we can say block is in equilibrium. When the block is in equilibrium, there are two forces acting on this block. One is weight of the block that is acting down. So simply we can write down weight of the block is acting down. The second force, as this is in the fluid, so there is an other force that is acting on this block, and that is upthrust. So there is upthrust acting on this block. If we draw the free body diagram for this one, so we can simply draw weight is acting down, so this is W, and upthrust is acting up. And these two forces, they are equal in magnitude, but they are in opposite direction. So this one is upthrust. So these two forces are acting on this block as this block is stationary. So these two forces are equal in magnitude but opposite in direction. So simply we need to write the names of these two forces. So we can write down one force that is acting upwards, that is upthrust, and the second force that is acting downwards, that is weight. So we have to write down names of these two forces. And this question has only 1 mark. If you have written these 2 points, you will get 1 B mark. For part B, it is given to us the block is now displaced downwards as shown in figure 3.2, so that the surface of the water is higher up the block. It simply means that before block was inside water up to this point, means this much block was inside water, but now we push this block downwards and now this much block is inside water. So more part of the block is inside water. So it simply means that upthrust in this case will increase because upthrust is equal to weight of fluid displaced. So we can say upthrust is equal to weight of fluid displaced. Now the block is displacing more fluid, weight of fluid displaced. Now block is displacing more fluid. As block is displacing more fluid, it means upthrust on the block will increase. So this is first piece of information we can get from this given information. Now let's move on to next. What question is asking us? Question is asking us to state and explain direction of the resultant force acting on the wooden block in this position. Means when the block is in new position, what is direction of resultant force? We have already discussed there are two forces acting on the block when the block is stationary. One was weight. So this is weight of the block. We can simply write down this is weight of block that is acting downwards, but weight of the block does not change because weight of the block is depending on mass of the block and value of G, but upthrust is depending on weight of the fluid displaced. Now we displace more fluid, means the block is displacing more fluid, so upthrust in this case increases. Before upthrust was equal to weight, but now in this case weight of the block does not change, but upthrust has increased. So it simply means that there is resultant force in direction of upthrust. So we can write down F net in this case is upwards. So first thing we have to write down down. So we need to state. So we can say resultant force is upwards. So this is the first thing we have to say. So we can say as upthrust increases, because weight of the fluid displaced increases, so the upthrust is greater than weight. So we can say as upthrust increases. So simply we can write down here as upthrust increases, and upthrust is greater than weight of the block. Now upthrust is greater than weight of the block, so F net is upwards. So F net is upwards. These points we have to write down to answer this question. And this question has only 1 mark. Let me show you how you can write down your answer. In your answer, you can say as upthrust increases, as upthrust increases and upthrust is greater than weight of the block, so resultant force is upwards. If you have written this one, you will get 1 mark, and that is B mark. For part C, it is given to us the block in B is now released so that it oscillates vertically. It simply means that first of all we push the block down from equilibrium, and then we remove the force. When we remove the force, block will start oscillating up and down vertically, and the resultant force acting on the block is given by this expression. F is equal to minus ag rho x. X is the vertical displacement of the block from equilibrium. For part 1, we need to explain why the oscillations of the block are simple harmonic. So first thing we need to understand, when we can say oscillations are simple harmonic motion, so we need to understand the basic condition for simple harmonic motion. So we can write down conditions. Any object, if it is oscillating and do simple harmonic motion, then it has to obey A is directly proportional to negative x. Mean acceleration has to be directly proportional to x, that A and x, they have to be in opposite direction. So we can write on here, first condition is that A has to be directly proportional to displacement. Mean acceleration has to be directly proportional to displacement. And the second condition is that A and x, they have to be in opposite direction. So we can write down the second condition, opposite directions. Means when A is positive, x has to be negative, and vice versa, in opposite directions. But this is also true if you look at F is equal to ma, resultant force is equal to ma. If mass is constant, then F is also directly proportional to A. If mass is constant, F is directly proportional to A. In this case, mass of the block is constant, so we can also say that F, if it is directly proportional to x, and if direction of F and x is in opposite direction, mean directions of F and x, they are in opposite directions, mean when x is positive, F has to be negative, and when F is negative, x has to be positive. If these oscillations, they fulfill these conditions, then we can say these oscillations are simple harmonic. Now if you look at given equation, F is equal to negative ag rho times x. In this case, these 3 quantities, they are constant. Area of the block is constant, cross-sectional area G is constant, and density of the fluid is constant. So one point we can say in this case, A, G, and rho are constant. Rho, this is density of the fluid. Rho are constants. As these are constants, rho and G are constant, then we can say F is directly proportional to negative x. And this is condition for simple harmonic motion. F is directly proportional to x, but F and x, they are in opposite directions. So F is directly proportional to x. If you write down this one, you will get 1 mark. In order to get second mark, we need to write down the second condition for simple harmonic motion. Or simply, we need to explain this minus sign. This minus sign simply tells us that f and x, they are in opposite directions. So we can say f and x are in opposite directions as indicated by negative sign. So we can write down as indicated by minus sign. That's all what we have to write down for this question. This question has 2 marks. You will get 1 B mark if you have written the first one. And the second one you will get if you have explained minus sign. For the second part, we need to show that angular frequency omega of oscillations is given by this expression. But for this question, F net is given to us. F net is equal to negative AG rho times X. This is F net. So let me write down here. This is F net. But F net is equal to MA. So we can replace F with MA. So MA is equal to negative AG rho X. From here we can find expression for A. So we can write down A is equal to negative AG rho divided by M. So divided by M times X. We also need to understand the general equation for simple harmonic motion. And general equation for simple harmonic motion is A is equal to negative omega square X. So this is general equation, or you can say the basic equation for simple harmonic motion. So we can write down this is general equation for simple harmonic motion. So any object which is doing simple harmonic motion has to obey this equation. So A has to be equal to negative omega square X. But now if we compare these two equations, we can get value of omega. So here, so in this case, we have negative omega square. By comparing these two, we can write down like this, omega square X. This is equal to negative AG rho divided by M times X. X is common on both sides. We can cancel this. Negative sign we can cancel with negative sign. So omega square in this case is equal to AG rho divided by M. We need omega. So we have to take square root on both sides. So this is our final answer, and this is what we need to show. So this is our final answer. This question has 2 marks. The first mark you will get if you have written this. If you have written A is equal to this, you will get first mark, and that is M mark. Means you have to write down this expression. So then you will get this mark. And the second mark is answer mark. Here is answer mark. But condition is that you can get A mark only if you get M mark. If you don't get M mark, let's say you got 0 here. If you got 0 here, you will also get 0 here. Answer mark also will be 0. So this is must mark. So you have to write down this expression first, and then you need to get omega. M is must. But if you got M mark, this answer is wrong, for example, then you will get M1 here and you will get A0 here. But if you got 0 mark here, you will also get 0 mark here. Even this is right. So you have to be very clear with this expression. You have to write down first this one, then you have to write down this. For part D, it is given to us the block is now placed in a liquid with a greater density. The block is displaced and released so that it oscillates vertically. The variation with displacement x of the acceleration A of the block is measured for first half oscillation as shown in figure 3.3. For part D1, we need to explain why the maximum negative displacement of the block is not equal to maximum positive displacement. The value of maximum negative displacement is equal to negative 0.02, and the value of maximum positive displacement, so we can find out from here, and this value is about 0.016. So in this case, maximum, this is amplitude, but simply you can write down negative maximum displacement. The magnitude of that is greater than positive maximum displacement, or simply we can say in this case negative 0.02. This one is greater. We are talking about magnitude. Negative simply tells us direction of displacement, and this one is greater than 0.016. We need to explain this why is like that. So the first thing you need to understand in this case is, as amplitude is decreasing, if you look at energy of oscillations, we can say the total energy of oscillations, that is equal to 1/2 ma square omega square. So this is total energy of oscillations. In this case, amplitude is decreasing. It simply means that energy of oscillations is decreasing. So we can say in this case, ET of oscillations decreases as amplitude is decreasing. So we can say energy of oscillations in this case is decreasing. Why it is decreasing? So we can say this is due to damping, because damping is involved. So energy of oscillations is decreasing due to damping, and damping is caused by, so we can say damping is caused by viscous forces, means forces due to fluid. So we can say due to viscous forces. That's all what we have to write down. Now let's try to write down the answer for this question. So simply we can say in this case energy of oscillations decreases. So we can write down energy of oscillations decreases. Energy of oscillations decreases due to damping. Energy of oscillations decreases due to damping. And damping is caused by viscous forces due to damping. And damping is caused by viscous forces. And damping is caused by viscous forces. That's all what we need to write down for the answer of this question. Caused by viscous forces. That's all what we need to write down. And this question has only 1 mark. If you write down this, you will get 1 mark. Means this has to be in your answer. You have to mention damping, and you need to say damping is caused by viscous forces. For the second part, it is given to us the mass of the block is 0.57 kg. Use figure 3.3 to determine the decreased delta E in energy of the oscillations for the first half oscillation. For first half oscillation, we have already discussed negative maximum displacement is equal to negative 0.02 meters, and positive maximum displacement is equal to 0.016. Now we need to calculate energy. So first thing, let's try to understand what is total energy of oscillation, E total. Total energy of oscillations is equal to kinetic energy plus elastic potential energy. If we talk about equilibrium, at equilibrium, displacement is equal to 0. At equilibrium, displacement is equal to 0. If displacement is equal to 0, it simply means that there is only kinetic energy, means the total energy is only equal to kinetic energy. So EPE is equal to 0. So kinetic energy we can write down. Kinetic energy will be equal to 1/2 m V max, because at equilibrium speed of the block or any oscillator is maximum, and V max is equal to, in simple harmonic motion, is equal to A times omega. So this is V max. So simply we can replace V with A times omega. So this is A omega square of this. So total energy of oscillations is simply equal to 1/2 m A square times omega square. Now for this question we have to find out decrease in energy, means we need to find out delta E, and delta E will be equal to E1 minus E2. E1 means we are talking about this point, and this is over second point. So we can write down equation for E1, so that will be equal to 1/2 m A1 square times omega square. Omega for the system is constant, so we can simply write on omega. And here we have 1/2 m A2 square times omega square. If you look at these two equations, 1/2 m times omega square, this is constant, so we can take this out. So we left with A1 square minus A2 square. Now simply we need to plug in values of A1 and A2 and omega and mass. Mass is given to us, A1 is given, A2 is given. So simply we can write down this is equal to 1/2. So we can plug in value of the mass. Mass of the block is 0.57, but we don't have value of omega square, so we will leave this one far apart. So we can plug in value of A1. A1 is 0.02. This is in meters, so we no need to convert this. So square minus, we have 0.016 square. Now, if we have value of omega squared, so we will be able to find the change in energy. Now we need to find out value of omega squared. If we remember general equation for simple harmonic motion, so we can write down that general equation and then we can find out value of omega squared. General equation of simple harmonic motion simply tells us that A is equal to negative omega square x. But if we compare this one with y is equal to mx, so m, the gradient, that will be equal to negative omega squared. So we can write down gradient of this graph, because we have the graph between a and x, so the gradient of this graph is equal to negative omega squared. So simply we need to find out value of omega. If we find the gradient, we will take 2 points. We will take this 1 point and this one we will take over second point. So we need to find out coordinates of these 2 points. If you look at coordinates of this point, we have negative 0.02 comma 2.3, and this point has coordinate 0, 0. So in this case we can write down minus omega square. This is equal to gradient, so we can find the gradient of this. So we have 2.3 minus 0, and this is divided by negative 0.02 minus 0. So it simply means that omega square is equal to 2.3 divided by 0.02. So we can find out value of omega from here. So this is value of omega. This negative, they are cancelled. So I can cancel this negative with this. So this is value of omega square. And this value we have to plug in here. So we can say this is 2.3 divided by 0.02. So this is omega square. Now we need to simplify this. If we simplify this one, our final answer will be 4.7 times 10 to negative 3 joules, and this is our final answer. So this is the decrease in energy. So this one is decreasing energy. This question has 3 marks. The first mark you will get if you have written this expression. So you will get C1 mark for the energy, total energy of oscillations. And the second mark you will get if you have written omega square is equal to gradient. Gradient is equal to negative omega squared. So you will get second C mark. And the last mark is answer mark. If you have got the right answer, you will get third mark. So this is how marks will be awarded. That's all what we need to understand about this question.